Today we're going to do a review on logs. Logs are nothing more than the inverse of an exponential. So let's talk about that a little bit. If I have 2 cubed equals 8, I can write that as a log. It would be log base 2 of 8 equals 3. So the form of a log would be log base answer exponent. Okay, so if I have a log, let's say log base 3 of 9 equals 2, I can write that as an exponent. 3 squared equals 9. All right, what else do I need to know about a log? Well, I need to know what it looks like. Every log equation is a curve, just like an exponential. Since it is the inverse of an exponential, if you remember, an exponential curve goes through point 0,1, well then a log is going to go through point 1,0. It's going to go in quadrants 1 and 4, and it's going to get as close to the y-axis as possible, but it's never going to touch it. So the characteristics of a log curve are, it's in quadrants 1 and quadrants 4. It goes through point 1,0, and the y-axis in this case is called that curve's asymptote, which means it's never going to touch it. Okay, let's talk a little bit more about logs. Well, there's also properties of logs where addition means multiplication, subtraction means division, exponents always come to the front. So it's going from a single log to multiple logs and multiple logs to a single log. Well, what if I have a single log, let's say log of the square root of y divided by x squared, and I wanted to write that as multiple logs. I would write it as log of, square root of y, that means raising to the half power, so it's an exponent, comes to the front, so it's 1/2 log of y. Division means subtraction, minus, I have an exponent again, 2 log of x. Okay, now let's go from multiple logs to a single log. If I have log of x plus 3 log of y minus 1/2 log of z, and I want to write that as a single log. Now you can only do that if all the logs have a common base, and in this case they do. Even though a base is not given, it's considered to be base 10. I would write it as log, so there's my single log. I'm only going to write the word log once. Let's see, x plus 3 log of y, 3's in front, so it was an exponent, so x times y cubed. Subtraction means division. Half was an exponent, so z to the half power, which also means the square root of z. So I wrote it as a single log. So now I know how to go from a single log to multiple logs and multiple logs to a single log. Okay, let's do log equations now. All right. If I have log base 6 of x equals 2, I can't put that in my calculator because I can't put the x in my calculator to solve it. So the only thing I can do is to change it to an exponential. So 6 squared equals x, 36 equals x. Let's do another one. What if I have log base x of 9 equals 2/3? Well, I can't put that in the calculator because I can't put an x for a base, so I'm going to change it to an exponential. X raised to the 2/3 powers equals 9. Oh, how do I get rid of that exponent? Oh yeah, I'm going to raise it to the reciprocal power of 3/2 and end up with x equals 27. So that's how I can change a log to an exponential in order to solve an equation when I can't use my calculator. All right, what if I have an equation that looks like this. Log base 3 of 2x equals log base 3 of 6. Well, I have a single log equal to a single log. They both have common bases. As long as it's only one log equal to one log, which means the word log is only written once on each side of the equation, and the bases are exactly the same, I can drop the logs or cancel them out and set the rest of the equation equal to each other and solve. X comes out to be 3. Well, what if I have something like this? Log base 3 of 5 plus log base 3 of x equals log base 3 of 7 plus x. Well, I have logs on both sides of the equal sign. They have the common base. I'm going to drop the logs. Oh, wait a minute. I can't drop the logs because it's got to be a single log equal to a single log. Even though they all have the common base, it still has to be one log equal to one log. Is there anything I can do to the left side to make it one log? Oh, yeah, and they have a common base, so in the world of logs, addition means multiplication. So I have log base 3 of 5x equals log base 3 of 7 plus x. Ooh, a single log equal to a single log with a common base. I can drop the logs. I have 5x equals 7 plus x. Subtract x on both sides. 4x equals 7. Divide each side by 4. And end up with 1.8 equals x. So I can eventually get an equation to fit the scenario where I can drop the logs as long as I have a single log equal to a single log with common bases. All right, let's move on. All right, let's talk a little bit about natural logs and base e. Natural logs and base e are actually reciprocals of each other, and they do cancel each other out. If I have e raised to the x equals 30, I can't put that in my calculator. Even though I have e raised to a power that I can achieve on the calculator, I can't put e raised to the x. So again, it's an exponential, so I see if I can turn it to a log. So if I turn it to a log, it'll be log base e of 30 equals x. But if you search your calculator, there is no way you're going to find log base e. I mean, you could actually put it in log and then type in the e and go from there. But what you could realize is that log base e actually stands for ln, and there is an ln button on your calculator. Ln and log base e are the exact same thing. They're called natural log. So it's ln of 30 equals x. You can put that in your calculator very easily and get the answer. So if I go ln of 30, I end up with, let's say to the nearest 10, 3.4. All right, let's do another base e. All right, what if I have 3 times e raised to the negative 2x minus 2 equals 6? All right, I have an exponential. I need to get the base and the exponent isolated. So the base is e and the exponent is negative 2x. So I'm going to add 2 to both sides. So I have 3 times e to the negative 2x equals 8. I'm going to divide each side by 3. I'm going to get e raised to the negative 2x equals 8/3. All right, what can I do here? Well, I can change it to, I can't raise each power to the reciprocal, raise each side to the reciprocal power because of the x. I can change it to a log. So if I do log, it's going to be log base e of 8/3 equals a negative 2x. Log base e stands for ln of 8/3 equals a negative 2x. I can divide each side by a negative 2 because I can put in ln of 8/3 into the calculator. and end up with a negative 0.5 equals x. So again, my rules are exactly the same when I'm dealing with base e, by either changing it to a log or seeing if I can use the rules of exponent. But what I have to remember is if I change it to a log, log base e stands for ln. All right, let's take a look at an example with ln. All right, what if I have ln of x plus ln of 2x equals 2? It is a log. It's just an ln, a natural log. I can't solve it because I have multiple logs on one side of the equation. You can only solve log equations if you're down to a single log. Either if it's a single log on both sides, you can drop the log, or if you get a single log on one side, you can maybe change it to an exponential. At this point, there's nothing you can do. But since I have a common log, I'll use the rules which hold true for natural as well as they held true for LOGs. Addition means multiplication, so now I can write it as ln of 2x squared equals 2. There's nothing I can do there as a log, so I'm going to change it to an exponential, but I don't have a base. Oh, ln stands for log base e of 2x squared equals 2. So all I did was rewrite it, ln as log base e. Now I'm going to change it to an exponential. Base, exponent, answer. Okay? I'm going to divide each side by 2 and get 3.694 yada 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 equals x squared. I'm going to square root both sides. Let's give it to the nearest tenth, and I'm going to get 1.9. So again, all the rules hold true whether it's a real log or a natural log. Okay? All right, let's do one last big example. If I have an equation that looks like this, 2,250 equals 750 times 1.0075 raised to the 4x. Solve for x. All right. The base is 1.0075. The exponent is 4x, so I need to get that isolated. So I'm going to divide each side by 750. And I get 3 equals 1.0075 raised to the 4x. Let's see, I can't raise it to the reciprocal exponent to get rid of the exponent because of that x. I can't find a common base. There's just no way. Well, I'm going to have to change it to a log. All right, let's see here. I would have log base 1.0075 of 3 equals 4x. I can put that left side in the calculator and I can divide it by 4, and I would end up with 36.8 if I was going to the nearest tenth. That would have been one way to solve it. Or here's another way I could have solved it. If I didn't realize that I could change it to a log, I could have given it a common log and said log of 3, and again, giving it a common log would be log base 10, so I could use the calculator, equals, in the world of logs, exponents come to the front, 4x times log of 1.0075. Divide each side by 4 times log of 1.0075 to get the x by itself. So the 4 would cancel and then the log would cancel, so I do get the x by itself, and guess what? I would get 36.8 also. So if I can't remember to change it to a log, I can give it a common log as long as you're giving each side one log and it's got a common base of base 10, so you can use your calculator. Hopefully this review cleared up a lot of things that you needed to have clear up for logs. Please feel free to review it as many times as you want. Have a good evening.